Hello, good day, everybody. We'll get started here in just a couple of minutes. We'll give people some extra time to get logged in. Appreciate you hanging on with us for a little bit. Okay, it looks like we have a good group of people that have logged in. Welcome, everybody. Thank you for taking some time today to join us. My name is Garrett Riley. Welcome to the Sustainable Rail Freight Solutions, brought to you by Downer and ZTR. Excuse me. I think I'm the lone American here, so I'll try my Australian and Canadian so that everybody can understand me correctly. So welcome, thanks for joining us. Before we get started, just wanted to let everybody know there is, in that sidebar that comes up with a GoToMeeting app, there is a section on there that says questions. During the presentation, if something comes up and if you have a question, please enter it in there. We're going to take some time towards the latter part of our presentation to answer any questions. So put any and all questions that you want in that section of that sidebar that should have popped up when you joined the meeting. And like I said, we'll get to those and we'll have an open forum as much as we can, and we'll try to get to all of your questions at that time. But thanks again for being here. Like I said, my name is Garrett Riley. I'm the regional sales director for ZTR. I'm actually located in Idaho. I know you're all geography experts, so I'm in the state of Boise. The capital of Boise is Idaho. That's where I can be found. So if you get angry, I'll move, but for right now I'm in Boise, Idaho. Also joining with us, we have Ashley Thompson. He goes by Ash. He's asked us to call him Ash. He's been around for about 16 years in various roles, business development, sales within the rail and transport industry. He's been at Downer now for quite some time. He's held senior positions across Victoria and Queensland, focusing mostly on business growth, bid management, and contract negotiations. Lucas Paul is the Director of Technology at ZTR. He is Canadian, so he is based at the mothership in London, Ontario, Canada. Not the nice London, but the other one. So it's London, Ontario, Canada, about an hour and a half to the west of Toronto. And again, like I said, my name's Garrett. Lucas has been around for a long time. I think, what'd you tell me, 15 years or so, Lucas, that you've been with ZTR, multiple roles. He's led engineering efforts at ZTR. He's had multiple different roles within the engineering group, and he's a great resource, a great asset for us. We'd probably be hurt without him. I've been around for about 16 years in the rail industry, various jobs, in and out of the rail, both on the mechanical side for locomotives and specifically a lot of time with rail electronics, both onboard and trackside, wayside. But now with ZTR, onboard electronics is really where I'm focused here in the US. Before we get deep and dirty into the product, just a quick introduction into ZTR, who we are. You might be familiar with us. We've been around for 36 years. 1987 is really when we got started and going. Our start we really got started with the idle reduction systems. The original owners, and they're still the owners, but they were EMD employees. They had an idea, and the folks at EMD in London said, your idea will never work. And so they said, we're going to go try it and see if it did. And 36 years later, it's still working. So focused on locomotives, modernizations. We've been in business designing control systems, different applications for onboard electronics. We've got a great staff of engineers, and located in surprisingly a very, very good spot. Globally, we have a global reach. We have resources outside of the US, outside of Canada, that are managing this business and that we're working with them. And so we're really excited, and we're excited to be working together with Downer. And I'll turn some time over to Ash.
Yeah, thanks, Garrett. And I'd like to thank the ZTR panelists and ZTR for making themselves available in the Australia-New Zealand time zone, which is generally not so favourable for our ZTR friends. Before I touch on and talk about Downer Rail and Transit Systems, RTS, I'll just touch on Downer as a whole and give you a little bit of an overview. We are the leading provider of integrated services across Australia and New Zealand, and our purpose is to enable communities to thrive. We have a key focus on national security and decarbonisation. We play in areas such as roads, rails, airports, gas, water, telecommunications, health, defence, many other sectors. We pretty much touch everything. Last year we turned over and consistently been turning over $12 billion, and we have a workforce of more than 30,000 people across Australia and New Zealand, which makes us one of the largest private employers in the land. For RTS Rail, we have a really proud history, 150 years across 15 different sites. We've manufactured and overhauled over 3,000 different types of passenger cars and locomotives. We have 3 flagship projects of recent time, one being HCMT in Victoria, Melbourne, the other one being QTMP in Queensland, where I'm in one of their manufacturing facilities currently for that project. And then for freight, we've just recently signed with Fortescue Zero to develop the world's most efficient battery electric locomotive. And the goal is to be production ready by 2027. Change slide, please. For the partnership that we've got with ZTR, since Downer has re-entered the freight market just over 2 years ago, when the embargo finished with Progress Rail, we had a clear focus on decarbonisation, and we find ZTR the perfect partner for us to help our customers reach immediate emission reductions. Downer being the local presence, we're able to offer in this partnership engineering support, undertake design modifications, installation, integration of the complete ZTR range. We're able to do this at a Downer site or any of your sites if required, and that support can be as big as large as required. Just lastly, before I pass back to the panelists, I will like to mention, and we'll go on to this at the end, that ZTR will be joining us at Ausrail, will be a part of our stand, which is really, really exciting. So please come and say hi, and I'm sure if you have further questions, we can go through them there. Thank you.
Thanks, Ash. And we'll jump into some products. Before, I just wanted to give a little extra background of ZTR and kind of I guess how things have transitioned to where they're at today. Like I said, it started in the late 1980s, but in the 1990s, we started getting into some adhesion controls. Our system called BOA, bolt-on adhesion, was something to just help with increasing adhesion, decreasing wheel slip, and taking more control over that. Together with that, we then introduced the idle reduction system in our SmartStart. We'll talk about that in detail with the AESS, and that really has led to some great things. And we transitioned into some diagnostic tools, some tools that we can get some remote information off, telematics, and trying to pull that data back into the back office of the different railroads so they can disseminate the information and try to make proactive decisions on what may be going on and what they might be able to do instead of reacting when it does happen. And then later on, the 2010s, then we started to get into some advanced systems, more control of the entire locomotive, not just bits and pieces of it, not just the starting and stopping, not just the wheel slip control, but then controlling the entire systems on the locomotive while maintaining the ability to stay connected and share that information from the locomotive back into the offices so that we can make even better informed decisions. And then we saw another gap that was created with all of these electronics getting on board the locomotives and a need for some help with the batteries. And so we've developed a supercapacitor and some additional battery management tools that go along with these advanced control systems on board. And we'll turn the time over to Lucas, and he can really introduce to us what that's about, what that looks like, and how it might be able to benefit you there in the Australian market and the markets nearby.
All right, thanks, Garrett. So starting off, we're going to go back to one of the original products that ZTR released, and that is the SmartStart. It was what started it all, as Garrett mentioned. But even though it was one of the original products, it still holds a lot of value and is very strong in the market today because of the emissions reductions and idle reduction that it offers. So what were some of the challenges that brought about this idea? Some of the things that we found within the rail market that posed an issue were manual engine management. So before any sort of automated engine shutdown, it required relying on the operators, people. There's a lot of things to monitor, and it's very difficult to be able to actually maximize your shutdown time when you're relying on humans that have other things to do, or that just don't have the time to be looking at all the different parameters on a locomotive. So it becomes very difficult to try and manage that. And instead of trying to manage that, in most cases, railroads just let the units run constantly, so they were always ready to be used, and then they would get shut down overnight or off shift when they weren't being used. Another issue that came about is, given that there's a complex ecosystem and a diverse fleet, there's different locomotive types, there are different models, ages, and they may require different set points to be monitored, different standard operating procedures in terms of shutdown or restart. So having complicated standard operating procedures to try and maximize your shutdown time, combined with the differences across the different units, can make it a very difficult training challenge to make sure that your operators are trained properly to be able to try and maximize that. And that just led as well to leaving the units idling all the time. Another issue was the uncertain quantification of benefits. In a lot of cases, the railroads didn't actually know what benefits they could stand to realize. They didn't know necessarily what their utilization was of their units, how much they were idling. In a lot of cases, they may have thought the units were being used quite often when in fact they may be sitting idle for a good portion of the shift that they would be used. Resistance to change is always a challenge to get over, especially when you don't have a lot of hard data to quantify the benefits. So with that uncertain quantification of the benefits, it made it very hesitant for anybody to really want to adopt technology. So they'd stick with their manual shutdown policies and get whatever benefits they could from that. And all these things would lead to inefficient emission reduction, tailing back to that whole manual engine management. So that's how AESS technology was born. As a quick overview, an AESS is an automatic engine stop-start system, and it operates by intelligently managing the engine's shutdown and startup processes. So this takes away the operating procedures around that automated or the manual startup and shutdown, and it monitors the correct parameters in order to know when it's appropriate to start up or shut down. These parameters are monitored by sensors and as well as some digital I/O for operational status and things like that. And it uses these sensors and this data to make real-time decisions based on some predefined criteria and thresholds so that it understands when a unit is in a position where it can be shut down without impeding operations, and when it's a good time to start it back up to make sure that it maintains all the parameters within a predefined range to allow for immediate operation without necessarily having to wait for the unit to get prepared to be operated. And through these, the AESS systems enhance operational efficiency, and they basically remove the human intervention and human error in those standard operating procedures from being required in order to realize the benefits of shutting down and reducing fuel consumption. So from this, SmartStart was born. It's the most trusted AESS in the industry, being the original one that was released. It's over 30 years of global history, so around the globe. And over 10,000 SmartStart AESS systems have been installed to date and continue to get installed as the years go on. So how does it work? Going back to the parameters that I mentioned, there's a few examples here. So things like brake pipe pressure, making sure that the unit is parked and the brakes are applied, one of the conditions for parked idle. So this is making sure that, operating, sorry, just a second, monitoring the operating inputs ensures that the unit is in a parked idle condition, that it's not being used so that the unit isn't shutting down and impeding operations. Ambient temperature is another item that it looks at. In a lot of cases, the set points will be right around that freezing mark. Just making sure that when you're shutting down the unit, you're not going to run into potential freezing of any of the water in the lines or anything like that. Engine temperature. This one's important to make sure that when it shuts down, that it restarts before the engine oil temperature drops outside of a range for standard operation. In normal cases where it's a manual shutdown, if the engine temperature drops too low, you can have a decently long wait time after you restart to make sure that you get the engine warmed up before you can load again. With a SmartStart in place, that's not an issue because it ensures that the unit's restarted before the engine temperature falls outside that range, allowing for basically immediate ability to load and get going right away. Battery health is another item that is monitored, making sure that hotel loads aren't draining the battery too low to the point where it can't restart again. So when it sees the battery voltage drop to a certain point, it'll make sure to restart the locomotive to restart the charging cycle and make sure the batteries get charged up again. Likewise, when the engine is running, one of the things monitored is the charging current to the battery, so that we make sure that we don't shut down prematurely with a battery that hasn't been charged sufficiently so that we can maximize shutdown time. SmartStart health status, another item that it looks at. This is making sure that the system itself is healthy, that all of the transducers and things that we are monitoring are working properly and healthy. And then lastly, the operator console, which is arguably one of the most important items that we look at to make sure that the unit is in a parked idle situation. Likewise, one of the things that is actually leveraged is the reverser handle. So you can actually use the reverser handle to start up a whole consist of SmartStart equipped locomotives. If you're sitting there waiting and you know that you're gonna start utilizing the unit in a moment, you can throw the reverser, and that train line signal across the consist will actually restart all the units within the consist to make sure that they're ready to go. So as mentioned, there's a number of parameters. This isn't an exhaustive list, but is a fairly standard one. There are some additional options, things like main reservoir pressure that aren't listed here, but can be a parameter for monitoring as well. As mentioned, ambient temperature, typically around the freezing mark, to make sure that you're not shutting down when there could be the risk of water freezing within certain parts of the water system. Engine water temperature is mentioned to maintain the operating temperature of the engines so that you're ready to go. Battery charging current, battery voltage to make sure that the batteries are not getting depleted too much and that they're being recharged sufficiently before shutdown happens. Runtime after loading, this is a configurable set point to a point within, as long as we're within the EPA certifications or any certifications that govern the locality where it is. Typically it's set to about 15 minutes. So what this means is that anytime the engine is loading, after you stop loading, it will wait 15 minutes before it attempts to shut down, just to make sure that if you're making moves and then waiting for small periods of time, that the SmartStart isn't shutting down the unit while it's being used somewhat regularly. Brake cylinder pressure, again, this is also making sure that the operator has applied the brakes and parked the unit before it goes to shut down. Reverser position, as mentioned, another operator input, and also a means to start up the whole consist. So some of the features and benefits. One of the main features, as mentioned as the challenges from before, fully automated operation. So it's very transparent to the operator. Really, they can just kind of leave the unit as long as they're making sure that they park it and apply the brakes as necessary. The SmartStart will go ahead and auto shut down whenever it's optimal, and make sure that the owner is realizing the maximum benefits possible and getting the maximum shutdown time available. And this leads to optimal emission reduction, making sure that the emissions are reduced as much as possible, saving money, saving the environment. And universal applicability, going back to the diversity of the fleets. This is one where it kind of removes a lot of those differences between the units because it's all automated. You don't have to worry about training all of your staff about what parameters to monitor because the SmartStart, once it's installed, is set up to do all of that, and they can just use the unit as normal and park it when they're finished using it, and the SmartStart will take care of the rest, and it'll be warm, available, and ready whenever they come back and need to use it again. So some of the benefits. With the SmartStart system, we monitor and log a fair amount of utilization data, so you get accurate and up-to-date data. This can be for compliance, this can be for reporting, this can be for monitoring the effectiveness and the return that you're getting on the product. So these data are logged by the SmartStart and available in some handy reports. There's detail reports that will go through the various parameters that prevent shutdown or cause restart. And in some cases that can lead to identifying issues with the locomotives and how they're operating. Perhaps you have a leak in the air system, and if you have main reservoir pressure as an option and it's triggering a lot of restarts, that may be an indication that there's some leaks in the air system, and tightening up the air system may result in additional realized savings. Another benefit, it's flexible, expandable technology. So generally speaking, we make sure that any of our products are easily expandable to adapt to new market requirements, new customer requests, things like that. So if there's additional IO points that want to be monitored or other items that come up, we try to make sure that we can expand the technology to address these market needs and add those additional options in the future. So some other options that come with SmartStart or available as options, load shedding. So there are options where when you do go through a shutdown, load shedding will actually cut off auxiliary lighting, headlights, ditch lights, things like that, significantly reducing the load on the battery while it's shut down. And this helps maximize your shutdown time because the voltage doesn't fall as far and you don't have to restart as soon to recharge the battery. Battery saver is another option that comes available with SmartStart. And this option is actually for those times when you have a manual shutdown or an improper shutdown, or maybe perhaps another engine protection device or something like that has shut the unit down. On that manual non-auto shutdown, battery saver will disconnect all non-essential loads after a certain time, so that when you get back to the locomotive, you don't have a battery that's completely drained, and you should be able to fire it back up again. So one of the things that we have available that partners quite well with SmartStart is our remote monitoring, otherwise known as Saver. So what Saver does is allows a lot of those reporting benefits to be accessed remotely without having to get on board the locomotive. So Saver offers GPS location geofencing. So this enables real-time tracking and monitoring of locomotives, as well as alerts when they enter or exit certain areas. Fleet reports, as I was mentioning with the detail reports, where you can see what kind of parameters are preventing shutdown or causing restart. These can be run on a more fleet-wide basis, so you can see if you have trouble units that aren't getting the returns and the savings that you're expecting. And then you can dig into the individual unit reports to see what parameters are actually causing a problem with that unit and not allowing it to realize the savings that it should. So these reports provide a lot of insight in terms of how the units are operating, as well as if there are maintenance items that could be done on the units to maximize the savings further. Additionally, there are some utilization reports as well. So even outside of the AESS operation, it can help give insight into how the units are being utilized, how much they're being utilized. In some cases, we've had customers that through these reports have found that units aren't in service and loading near as often as they thought. And it can actually provide data to help modify or change how units are deployed and maybe get them deployed in a more efficient manner so that they can be utilized more effectively. There's also automated alarm notifications. So these can be real-time alerts for locomotive events that then get emailed to selected people. Where something like this can come in really handy is if you have a unit that is, say, operating in freezing temperatures or near freezing temperatures, and for some reason there's a non-auto shutdown, say there's an engine protection device or somebody manually shuts down the unit and walks away and doesn't realize. This can give an alarm notification to let you know so that you can get out and either restart the unit or dump the water or whatever else needs to be done to make sure that there isn't subsequent damage due to that freezing. And then, as mentioned, operational insights. So you can uncover the patterns, trends, and other opportunities to drive areas of improvement and better efficiency, largely from the utilization reports. So with all of those things added together, what we've seen from the standard usage that we see in the use cases that we get is a break even of less than 1 year and per unit yearly savings of on average 20,000 to 30,000 liters of fuel savings. So moving right along, KickStart is a relatively newer product from ZTR, and this goes back to the supercapacitor technology that we were referring to earlier. So where did the need for KickStart come in? So decades ago, lead acid batteries were basically used solely for starting, and this is what they were intended for. This is where their strength really is. Basically, they would have a heavy load, start up a unit, and then they would get basically trickle charged for hours on end as the units just stayed running pretty much all the time. So those decades ago, lead acid batteries lived a happy life. They were utilized as they intended. The charging fit very well with the lead acid battery lifespan and charging profile. Starting and stopping was relatively infrequent, so you had long engine idle times and not a lot of stops. And the hotel loads weren't as much of a big deal. A, because there weren't near as many electronics to power, things like distributed power and all the computers that run now. But also the units weren't shut down that often, so the hotel loads were just fed off the auxiliary generator, and you didn't have to worry about the batteries getting depleted all the time. So fast forward to today, lots of legislations and other drives for efficiencies and running the engines all the time. It doesn't really line up with that very well. So today the batteries are not really meeting the required needs for a locomotive anymore. The charging is often not adequate. There's not a lot, as near as much engine idle time, so you don't get those very long saturation charges happening the way they used to. Your starting and stopping is a lot more frequent because of trying to reduce the emissions as well as the fuel consumption. So you have starting and stopping happening quite a bit more. And the hotel loads have gotten exponentially larger. So with things like your safety systems, radios, distributed power, all the things like that, it does not take very long for a shutdown locomotive to have the battery drain out fairly quickly. So from that, supercapacitor technology has come in and makes a really strong case for addressing some of these issues. So this supercapacitor starting assist technology addresses these things at a reasonable cost and effort. Supercapacitors have a higher power density than batteries, which means that you don't have to necessarily look at a huge amount of space to get them installed. They recharge very quickly and discharge energy much faster than batteries, resulting in reliable engine starting performance, but also not having any sort of negative impact on their performance due to very large discharge rates. And also supercapacitors have much more consistent performance across wide temperature ranges, especially colder. So lead acid batteries, once they get below freezing, don't really like starting locomotives as much, and you get much further than that, and it becomes very noticeable how much their performance is degraded. Supercapacitors, on the other hand, pretty much from any temperature operate just as well, and you don't see that degradation in performance. So they can continue to deliver extremely high rates of discharge and large current peaks regardless of the temperature. And that's one of the areas where they really help to bolster some of the weaknesses of lead acid batteries. So this is where KickStart was developed. And how does it work? Basically, what we do is when the locomotive engine is running, while it's charging the batteries, providing the low voltage bus with the power it needs, we also use that time to charge the supercapacitor from the auxiliary generator up to the low voltage regulation voltage. Then once the engine shuts off, the supercapacitor is isolated from the battery system and disconnected, so to speak, in order to maintain its charge, and it can maintain that charge for quite a long period of time. So even on an extended shutdown period, the KickStart is fully charged and ready to go the next time you go to start. So during that engine crank cycle, the supercapacitor will connect with the battery starting circuit in parallel with the batteries, and that in parallel assist allows for higher peak torque to successfully start the engine. But it's not just about a higher peak torque overall. The other aspect in which it's highly beneficial is that because the supercapacitor is there and allows for a much more rapid discharge, the contribution to the starting current from the battery is actually significantly less. And you see that from the voltage sag, and there's another chart we'll get to on that. But basically, because the supercapacitor is taking the brunt of that initial torque, the batteries don't get depleted as much. They don't get near as heavy a load on them, and because of that, the voltage sag is quite a bit less. So as I was mentioning, that voltage sag can cause a lot of problems. One being it makes it more difficult to start the locomotive engine. With that voltage sag, you don't get as much of the current delivery, so the engine doesn't turn over as fast. The other issue that can come up is the computer systems on some of these locomotives don't necessarily fare well with the voltage dropping even all that low. So getting below 45 volts or something like that, in some cases you'll see these computer systems reboot or brown out. And in some cases where that might be the control system, it could result in a failed or aborted start. In other cases, say with distributed power, it could result in some operational delays when you have to reset up the whole DP network across the consist. And that's just not efficient operation. So that's where KickStart can come in, and with the supercapacitor assist, prevent the battery voltage from dropping near as far so that your electronics don't reboot. And also with the increase in torque delivery to the starter motors, the engine is accelerated faster, so you spend less time at that low turning, and the quicker acceleration generally results in a faster start where the battery is not being relied on for that cranking energy for as long as without the KickStart in place. So some of the benefits that come from installing KickStart, thanks to the assist. Improved locomotive availability. The technology minimizes dead won't start events due to batteries, leading to increased availability and reduced maintenance costs because you're not resulting in units that are out and stranded because they can't start due to a low battery. There's additional fuel consumption reductions when paired with an AESS system. We've had some studies show that the technology improves AESS performance, leading to fuel savings, resulting cost reductions, and improving profitability and sustainability. And generally those fuel savings are coming around the area of the battery charging time. So with a KickStart installed, we've found that the idle time due to batteries preventing shutdown is decreased, as well as a significant reduction in the AESS restarts due to battery voltage. So those two things combined have resulted in significant fuel consumption reductions as well as emissions reductions due to the reduced energy consumed during the starting event. And this has also resulted in extended battery life. The typical battery life of lead acid battery in a locomotive application with an AESS can be approximately doubled and likely expected to 4 years with the KickStart. And where some of that comes in is because of the additional assist, you don't actually necessarily need quite as much energy left in the battery for a successful start. So as your battery gets older and the capacity of it starts to diminish, when you get to the point where the battery on its own can't start the locomotive anymore, KickStart there with the assist allows it to continue being able to start the locomotive, and you can get further battery life out of the batteries. So what does the return on investment look like? So over the course of 1 year, there's 3 key areas in which we see a return with this product. First one being the fuel savings that I mentioned when paired with an AESS. So that results in just over $4,000 US in savings per year. The dead won't starts. This is coming from looking at any of the penalties, the time taken in labor to get a unit out to boost the unit, or any of the moves and logistics that need to be made to account for a unit that experiences a dead won't start. Generally came out to about an average of $6,000 US per year avoided by preventing those dead won't starts. And then the cost of the batteries, and by extending the battery life and not needing to change them out as often, averaged out to about $3,000 per year, totaling somewhere between $13,000 to $14,000 a year on return with the KickStart in 1 year. Extending that out to look at 10 years, and the reason we look at 10 years is because it is not unfeasible for the supercapacitor system to last well more than that 10-year period. So we picked that 10 years as kind of a conservative estimate of the lifespan that any customer would see with the KickStart product. It would actually be longer than that. But over that course of that 10 years with that ROI, you can see that the 10-year return is getting over 6 figures on the low, approximately $15,000 investment. So it's quite a return once you get a little further into the years. So moving from KickStart now onto NEXSYS. NEXSYS is what I would say is more of ZTR's flagship product. It's our full locomotive control system. And this was born from a number of challenges as well. Outdated technology. So in a lot of cases, things like the -2 control system, and then not throwing shade at the -2 system, I think it's a masterclass in analog circuit design. But there is a limit to what could be done without making it absurdly complex. So newer technology can allow for additional functions and things that just couldn't be done with the technology of the time. In addition to that, with that outdated technology comes a lot of obsolescence and sourcing issues. So challenges in getting replacement parts when you have parts fail, cards, things like that. Maintenance and reliability. Over time, as those parts start to fail more and more, you get a lot more maintenance items coming up, the reliability drops. In some cases, being able to source the components gets more and more difficult. A lack of integration and compatibility. In a number of cases, there are electronic systems now that interface with the control system on board newer OEM locomotives. And that option isn't necessarily in place when you have the old outdated technology there that just doesn't have those integrations. May not even be a microprocessor controlled locomotive, at which point you don't have the logging, you don't have the data there. Inefficiencies in fuel consumption and performance. So newer technology has better performance in terms of adhesion that can result in more efficiency, less fuel consumed. Things like integrated AESS on newer control systems also result in further fuel consumption reduction and emissions reductions that aren't there with the outdated technology. Regulatory compliance can be another one. In some cases, if you're overhauling locomotives, it may be a requirement to have newer technology that the current control system just doesn't support. Limited data analytics and insights, or in some cases, no data analytics and insights. In some cases, there may be test points you can measure with a multimeter and maybe not a whole lot more than that. In other cases, you may have some rudimentary interface with I/O points and things like that, but probably not a whole lot of logging, and definitely not a whole lot of data analytics or insights telling you things that can be useful in terms of highlighting some issues where you can improve your fleet performance. Limited remote monitoring diagnostics, like the data analytics. In a lot of cases, the older systems aren't going to have any sort of edge telematic connectivity. So none of that information, even if it was there, is available off the locomotive, requiring that any sort of information you're going to get from the locomotive is going to be very manual and is going to be required to be local on the unit. And then lastly, kind of bridging off of the last two items, a lack of predictive maintenance. Without any of that data, it gets very difficult to necessarily see the signs or any information from the locomotive that would suggest maintenance that coming up would be preventative to make sure that you resolve a failure before it actually happens. So these issues in the industry caused a lot of advanced requirements for locomotive control systems to meet. Seamless integration and interoperability. This goes both with the other third-party electronics and devices and things that are now more present all the time, but also making sure that in terms of what people are used to, how they're used to operating a locomotive, isn't significantly changed. Don't want there to be a huge training and learning curve for a new control system coming on in terms of how to operate the locomotive. So generally, we're looking for all these improvements in operation to come with a somewhat transparent standard operating procedure for driving the locomotive. Enhanced performance and efficiency. There needs to be a good reason beyond just old technology for replacing the control system, and that is the enhanced performance and efficiency that comes with it. So improved adhesion, the ability to pull more freight, as well as using less fuel while doing so, and making sure that all of the equipment while pulling more freight is not at an increased risk of being damaged, and that it's being protected by the control system so that you have fewer failures and fewer maintenance. Superior reliability and less maintenance, just as I mentioned. The reliability of the systems themselves and the components that get installed is higher because they're newer, they're not aged as much, and there generally should be less moving parts, less reliance on mechanical relays and things like that, resulting in less maintenance, as well with the improvement in data, the availability, that predictive or preventative maintenance should result in less unexpected failures. Improved safety and compliance. On top of improving the protection of the rotating equipment and the things like traction motors, the engine, stuff like that, there's also some increased safety. So making sure that the unit can't be operated in unsafe conditions, and making sure that beyond just protecting the equipment itself, that we're protecting the people operating it. Real-time data analytics and insights. Generally speaking, with microprocessor control of the more modern control systems, there is a slew of data available that the control system is already monitoring, and logging that and providing that and being able to draw conclusions from it and help use it to diagnose issues and things like that has a whole lot of value beyond all the other upsides and positives that come with the updated control system. Scalability and flexibility. I know I mentioned this with the SmartStart, where we generally try to make sure that things are scalable and flexible, and this couldn't be any more true with the control systems as well. There's constantly more items that could be monitored, more things that could be controlled. So making sure that there's scalability and flexibility to be able to adapt to and support those future requests without necessarily having the foresight to know what they might be is incredibly important when it comes to the full locomotive control system. Remote monitoring is getting more and more important all the time. The industry is making it very clear that they see the value in data and what data can bring. So having that remote connectivity to be able to get those real-time data analytics and insights off the locomotive is becoming increasingly attractive all the time. And most of all these things need to come together to have a cost-effective investment and a good ROI to make sure that that you're getting value out of the investment in the first place. So what are some of the features and benefits of NEXSYS, speaking to all of these things that on the previous slide? Propulsion efficiency. So NEXSYS I do have a slide coming up on this, but NEXSYS has been shown to have a significant increase in dispatchable adhesion. And what that means is that you can pull more freight at a lower speed. So that in some cases can either allow you to pull longer trains or pull the same trains with fewer units in consist. Reliability and availability. We replace a number of the old relays that were there with microprocessor technology. So there's less mechanical parts, less moving parts, and the parts that are there are generally newer. That availability is also impacted by the onboard diagnostics that I'll get to a little bit later. But by having better diagnostics and better information, we allow for shorter times in the shop, make sure that when there are issues with the locomotive that it's much clearer, the troubleshooting is more intuitive to make sure that problems are found quicker and units can get turned around faster out of the shop. Emissions and cost reduction. I'm not sure if I mentioned it, but the NEXSYS 3i does include an integrated AESS or integrated SmartStart. So it has all of the emissions and fuel consumption reductions that the SmartStart has built right in. So through that, we get emissions reductions. Also through the propulsion efficiency, there's emissions reductions just because you're utilizing either less units or you're moving more freight with the same emissions. So your emissions per ton go down. The onboard diagnostics, this is incredibly beneficial and one of the largest benefits over coming from older technology to newer. We have a full color interactive display, and that diagnostic panel allows for flow charts and things like that to make it very intuitive to troubleshoot the unit and understand what's going on. And sometimes even it's not just troubleshooting, but just understanding what the unit's doing, how it's operating, and a lot of that information is available through the onboard diagnostic display. We also offer an integrated locomotive display. This is typically an operator display that would go on board the control stand. So it would show things like speed, the brakes, and braking information and stuff like that. So that is separate from the diagnostic display that's typically mounted on the high voltage cabinet or near the engine control panel. And we do offer remote monitoring with the NEXSYS on top of all of the remote monitoring that you get with SmartStart with the Sabre. There's also a lot more information around the utilization. There's push faults, things like that. I'll get into that a little bit further. All these things combine to provide an excellent ROI for the NEXSYS, making sure that your investment is returned in a short fashion. So going back to the propulsion, we did some testing at a wholly owned subsidiary of the AR, TTCI. This was third-party testing that was outside of our company. And what we found is with the NEXSYS 3i installed on an SD40, which is an EMD unit similar to like a GT26, against the Dash 2 system and the NEXSYS, we found with dry rail testing with no sand that we had a 44% increase in our adhesion at 2 miles per hour. And you can see from the graph what we've got there is the red line depicting the Dash 2 and the adhesion that it was found to have, and that was actually measured by TTCI. And then we've got the green line reflecting the NEXSYS adhesion, And just almost overlapping that is the blue line, which is basically your theoretical maximum adhesion based on the power and the current limits available on that unit. So you can see with the NEXSYS 3i in place that we're just shy of those theoretical limits where without increasing the current limits that the motors can handle, we're basically capping out on the maximum adhesion that these units can get. And then further with wet rail, the improvements aren't quite as big, but you can see that the NEXSYS still has a substantial advantage over the Dash 2 system with no sand, I might add. And that was a 29% increase at 2 miles per hour. So we're a little further away from that ideal, but not dropped as far as the Dash 2 unit does. So going back to the onboard diagnostics, there's a few examples here of some of the screens that can be found. You can view a number of things, main locomotive parameters. There's real-time viewing screens for the different modes of operation you're in, whether you're in power, load test, DB, that will show trend charts or bar graphs of the different traction motor currents and voltages, main gen currents, voltages. There's pages to monitor the voltage regulation, so you can see what your battery charging current looks like, how your low voltage bus is being regulated. Beyond that, there's system health status that can be monitored. You can look at all of the transducers and make sure that all the transducers are healthy, that there's nothing that's causing the NEXSYS system to be disabled. There's output test and advanced diagnostics. So you can put the unit into a diagnostics mode straight from the HMI, and from there you can force on outputs to do testing to make sure that they're connected to the right devices, ensuring that relays or contactors that it's outputting to are being energized, as well as perhaps just running tests with multimeters and things like that. There's a number of pre-departure tests. These are things like testing the wheel slip light. There's a main reservoir relief valve test, making sure that the relief valve actually functions, where you can overcharge the main reservoir outside of normal operation. There's fan tests, where you can actually make sure that the fans are rotating by forcing the outputs, provided that the engine temperature is within correct ranges to do so. And then further to that, we have some automated tests. There's an automated contactor test, an automated load test. With the automated contactor test, you basically start it up and it runs through and goes through all of the outputs and monitors the feedback inputs that we have. And if it sees any mismatches or any contactors aren't picking up when they should, it'll flag a fault for that and then send that back through the remote monitoring. The automated load test, likewise, basically the operator has to put the unit into a situation where it can load. And then from there, it will automatically run up through the notches, make sure that everything is up to temperature and good, and then take it right to notch 8, get it loaded up to full power, hold for a set period of time, because generally it's good practice to make sure that your load tests are held for a while. And then at the end of the load test, it'll take a data log and log whether or not the load test was success or failure based on whether or not it was able to meet the rated horsepower. In addition to that, there's a lot of troubleshooting information. So we have these flow charts. There's one you can see over in the bottom right there, the auto restart diagnostics. So there will be a number of criteria that are required for an auto restart shown there on the left, and then from there there's a flow chart of sorts showing the different conditions that are required to be satisfied in order for a certain activity to happen. Like the auto restart diagnostics, there's also some okay to load diagnostics for the different modes, where they'll actually show the different conditions required for the GFC to be able to pick up and for you to be able to start loading. And likewise, they run through the various different criteria that are there and show in real time which ones are satisfied and which ones aren't. And in most cases, if there's sub criteria, you can actually dive into a given shown criteria that's not satisfied to see the further items that contribute to that. So basically it allows you to drill down until you find the root of the issue in order to be able to quickly fix it. And then reports, I mentioned it has all of the same reports that the SmartStart does. So it's got detailed reports for fuel savings and the parameters preventing shutdown and initiating restart. as well as full duty cycle, utilization. There is an event logger for all the starting events, as well as we have crew messages that will pop up whenever there is conditions on board the locomotive that may alter the operation of the unit. So an example of a crew message could be short-term thermal protection. So on older units, you had to manually monitor when you were going into the yellow or the red zone of your amp meter, basically, and then time it to make sure that you weren't overheating the motors. That is done automatically with the NEXSYS control system. And not only that, if you go through that short-term thermal time period and time out, it will derate down to the continuous current to protect the motors, but provide a crew message to let the operator know why that derate was happening, so that if they're wondering why they suddenly were loading lighter, there is an indication to let them know why. So another aspect of the NEXSYS control system that I mentioned is our integrated locomotive display, or ILD. This is an operator display. You can see there it's showing the speedometer as well as a number of braking system parameters like brake pipe, equalizing reservoir, main reservoir, things like that. This would sit on the control stand and replace the mechanical gauges. In certain localities, this can actually enable moving to 184-day maintenance versus a 92-day because of the removal of those mechanical gauges, and they no longer need to be calibrated. It can also interface with the head of train, end of train, so that you're giving one interface there. Likewise, electronic air brake, distributed power. Basically what it's doing with a lot of these systems that it can integrate with is that instead of having a screen to interface with each one, you have one screen that can interface with all of them consolidated in one location. So you can run through you know, the test screens and test phase with the electronic air brake with CCB2. Likewise with the head of train, end of train, you can arm through this. And then likewise, there is available built-in vigilance where you can get your alerter functionality and such through the ILD, and then also showing ground speed. So how does the control system work? There's a lot going on here. I understand that, so I'm not going to go into every little piece that's on here. But generally speaking, the stuff in green that's highlighted is part of the NEXSYS control system or the ancillary accessories that come with it. So there's a few different areas of the NEXSYS control system and its operation. Mainly one of them I was talking about is propulsion. So the adhesion control and power control. Not sure why I just... Sorry about that. So there's the adhesion control, power control. So it's controlling it's monitoring the operator stand, the operator's inputs from the throttle handle, things like that. And it is using those signals and sending them to the engine to make sure the engine's spinning at the right speed. And then subsequently interfacing with the SCR that's there in this example for an EMD unit, and controlling that SCR to the AR10 main winding. So in that regard, it's controlling the engine speed, and then it's controlling the amount of load that is being drawn from the engine through the AR10 and delivered to the traction circuit. And as part of the traction control, we monitor the whole traction circuit with voltage and current transducers. And unlike some of the older control systems where they may not be monitoring them individually, we do have individual voltage and current for each traction motor. And through those voltage and current feedbacks, we determine when there's a slip happening without the use of a ground speed reference and without complicated radar or things like that. Additionally, the NEXSYS, as mentioned, has integrated AESS, so there's also the items that come with that. We've got our governor assist pump labeled there, the interfaces with the operator as well as the engine for the automatic startup and shutdown. We have integrated voltage regulation. So there is an exciter module that controls the low voltage bus going to the oxygen field. And that controls the low voltage bus, which also controls the battery charging. So the NEXSYS does 3-stage battery charging to result in more efficient charging of the battery. as well as making sure that the low voltage bus is regulated and stable for all the loads that are on it. We also do compressor control, engine temperature control, so we control the fans through the contactor control. And then lastly, we've got shown there the CHUM, crash hardened memory, that interfaces directly with our LCM. So our LCM will grab data from the NEXSYS control system and make sure that it's stored locally on the crash hardened memory. And then also the LCM connects to our cellular network to make sure that we're offboarding all of the necessary information so that those handy reports can be run remotely, as well as any fault information can get offboarded and effectively presented to the user as well. And speaking of that stuff remotely, our remote monitoring platform with our NEXSYS control system. So we have all the same remote information that comes with SmartStart, and that comes in on a periodic basis, generally multiple times per day in terms of the utilization, the accumulators for the different restart and shutdown parameters. But additionally, we also have push notification, real-time push notifications of any faults that happen on board the NEXSYS control system. So those faults will come through real time and show up in the portal basically as soon as they happen. And through that portal, you have 24/7 access to that data on any of your equipped locomotives without having to get out and get on board the locomotive to download or view the data locally. So in addition to that data collection, we have some of the same fleet management tools that are available with SmartStart, as well as some additional ones. And additionally, we do have API integrations available for customers that want to ingest that data into their back office or their own back office suite. So that's definitely something that we have experience with in the past, and can leverage that experience to meet the needs of whatever the customer needs. So emissions and cost reductions, obviously we have the SmartStart stuff, but we also have the additional efficiencies gained through the NEXSYS control system. Generally what we've seen is that high use, high in service fleets see a lot more savings in return, and I think intuitively that makes sense. They're going to have potentially more idle time reduction. But also the more they're using a unit, the more you can take advantage of the efficiency gains in adhesion and things like that. And also the more units used before our control system, probably the more maintenance that had to be done and the more components that were being potentially broken, especially traction motors and things like that if they didn't have adequate protection. So what we've seen is, with this high service fleets and, on average 28,000 per year savings, and then down into, the lower service down as low as, just shy of 5K a year savings for a fleet that's not really being used all that much, which may potentially be an issue in itself. Supporting that a little bit, we did have a little bit of a case study here. We had a client with our NEXSYS 3i installed that actually found after the installation, they had a 90% reduction in their DC traction motor replacements due to the NEXSYS motor protection algorithms and specifically the short-term thermal protection. So with a client that we have that had changed over 1,000 DC traction motors annually due to flashover, thermal damage, commutator burns, anything like that because of stall currents. In those cases, we'd be looking at reducing that by 900 replacements, so down to 100 replacements. And with a general average about $20,000 per traction motor, resulted in about $18 million in savings over the course of a year just in traction motor replacements that were prevented alone. So going a little bit further into the return on investment, the AESS is there, so the integrated SmartStart as mentioned, with about that $15,000 to $16,000 in savings per year. And then additionally, we have some savings due to Smart Low Idle. Now I hadn't mentioned Smart Low Idle previously, but Smart Low Idle is an option with our NEXSYS. Some people may be familiar with low idle and low idle panels of the past, where there were issues with the low idle panels that typically it was pretty much just looking for you to be in idle, and then it would drop to a low idle using the A&D valve. One of the issues was that it wasn't really looking at any tertiary circumstance. So in instances where you were, say, trying to charge a train, it would charge the train slower. More detrimentally, in cases where the battery was charging relatively heavily, we actually had customers tell us that low idle was causing their oxygen fields to get burnt out because the oxygen fields are being driven basically to 100% and having full voltage applied in order to keep the battery charging current up. But those fields aren't meant to be fully driven all the time, so they were seeing premature failure of the oxygen fields on their locomotives because of low idle. So what did we do differently with Smart Low Idle? Well, with the control system they have in place, we have enough information. We're controlling the oxygen. We know what it's being charged to. We're controlling the compressor, so we know what the main res is. So all those things combined for us to be able to add a little more intelligence to it and make sure that we're not putting the locomotive into a situation where low idle could actually result in some sort of equipment damage, but still allowing the ability to reduce fuel consumption, because low idle does consume less fuel than regular idle does. So that's where that $8,600 comes from, is the Smart Low Idle, reducing fuel consumption even further in the conditions where it can be run. And then lastly, the improved traction. In some cases, you can remove, one of every 3 engines because of the 44% increase in tractive effort and adhesion at low speeds. In other cases, that savings can actually be from increased trains that can be run due to the additional adhesion available. So the total brings us up to close to $40,000 per year per unit, which is quite the return, and a summation of all of these items together. And that is it for now. I'll turn it back over to Garrett to moderate some of the questions.
Wow, that was a lot of information. We're gonna make this available for everybody. We'll post it, so you'll get a link, I believe, after the presentation's over, probably the next day or so. Excuse me, a recording of the presentation. So don't fret if you feel like you missed something. Obviously, you'll be able to get back to it and view it at your leisure. Some of the questions, and we appreciate the questions came through. Lucas, thank you very much for the information. He was riding solo. There was another gentleman that was going to help us, and he fell ill. So we appreciate Lucas for filling in and helping us out today. Thank you so much.
My
first question that came across, Lucas, if you could answer, was the KickStart system also integrated into the NEXSYS system?
No, it's not integrated, but it is complementary. So just like the SmartStart, where having the KickStart installed with it gets you additional savings, same thing here. So if you have the NEXSYS with integrated SmartStart there with a KickStart, you can see additional fuel savings because of it. Part of the reason that it's not integrated is that honestly, a lot of the components are, there's not really overlap between them. So leaving them as a more modular product offering just made sense.
So as a follow-up, how does the battery start management built into the NEXSYS system, is it complemented by the KickStart, or how do those two work together?
Yep, just like the SmartStart, you'll see those additional savings in that complementary. That said, although the KickStart is not integrated from the point of view of the controller and things like that, we do have integration in order for the NEXSYS to get additional information from the KickStart, and it provides that remotely. So that as well can help improve the data that you get back, and give you some view into how the KickStart's operating, making sure that it's working properly. If there's any faults, those will come through real time as well, not just with the NEXSYS, but with the KickStart passing through the NEXSYS.
So that's fantastic. So not only will the NEXSYS help us in the starting of the locomotives, but it'll together with, the KickStart, but together with the NEXSYS, we'll be able to see some data and know where our batteries are at, if we need to maintain them, if we need to replace them proactively, so that we don't have any additional failures later on. That's pretty awesome. Another question is, how programmable is the interface and features of the NEXSYS onboard diagnostics? Can it be customized?
So, I mean, that's a bit of a gray area because I mean, it can be customized to just about anything. But to that end, sometimes we find that offering too much customization can get yourself into problems. So we generally use industry feedback and best practices with the operations that we've seen to kind of get it where it is. In a lot of cases, though, there is interface for being able to change certain set points and things like that. In some cases where customers have fleets with different units, we might run the same software with some configurability in the HMI so that reducing the logistical complexity that the customer has to go through in terms of maintaining their fleet, things like that.
That's fantastic. Thanks, Lucas. So there is some flexibility in there. It's just a matter on how flexible we can be and how creative you want to be as a locomotive owner. So thank you for those questions. A couple other questions, specifically to SmartStart. Is there added maintenance with the addition of SmartStart to a locomotive?
So there might be a little bit. Obviously, if you're using your starter motors more often, they do have a given life cycle, so you might find that you're going through that life cycle a bit quicker. In other cases, it might not be as much of a difference as you might expect, just because previously a lot of the times starts would be happening from a cold locomotive. And with AESS installed and properly working, you're starting up a warm locomotive, which is, much less hard on starter motors. So there's a bit of give and take there, but I don't think that you end up with as much more maintenance as you might expect.
So tell us about, and just a follow-up question to that, tell us about how the KickStart complements some of those issues you just brought up that are inherent with an auto reduction system, starting and stopping all the time. How does the KickStart alleviate some of those issues, if it does?
So KickStart helps a lot with the battery and extending battery life. Generally speaking, a battery does have a finite amount of power that can go in and out. So anytime you're reducing the amount of power that is going in and out of a battery, you're extending its life. So KickStart has benefit there. The other aspect of it is that KickStart results in significantly reduced crank times in certain cases. So that reduction in crank time, generally you're going to see a reduction in the amount of time that your components are being subjected to these high energy loads, and that should help reduce some of the strain on those devices.
Awesome. Sounds like the perfect marriage to me. I'll take two of them. So why don't we jump along? I think there was one more thing. I'll turn a little bit of time over to Ash to talk about some upcoming events.
Sure. Thanks, Gary. I think there's one more slide. If you can look over, mates, would be great. There we go. Perfect. So, Lucas, thanks for I know you did all the heavy lifting there and talking through the product range. So really appreciate that. So really well done. So as I mentioned at the start, ZTR will be joining us on our stand at Ausrail, which is from the 26th to 27th of November. We're at stand 173. And I know there was a few questions around the NEXSYS system. We're actually going to have a live demo system on the stand where you'll be able to touch, play, go through the different options and modes. It's a bit of a simulator, so I think that might be worthwhile coming over and visiting and having a look. So yeah, that's it from me. And again, I really appreciate ZTR's time for this, knowing that the challenges with the different time zones. So thank you very much. Thank you, Lucas. Thanks, Gary.
Yeah, my pleasure.
Thank you, everybody. And if you have any additional questions or if you need anything else, please reach out to Ash. He's always available for those questions, and we'll be able to support with that. And with that, we will say goodbye. We hope to see you at Ausrail here in just a couple of weeks. So we look forward to it. And if you find Ash attractive in the orange, just wait till you see him at Osrail. It's going to be awesome. Awesome.
Way too kind, Garrett. Thanks.
All right, everybody. Cheers.